name is Mark Schwank. I'm a metal sculptor.
I'm Veronica Wilson.
Hi, my name is Helen Herlacher, and I'm happy to invite you today to look around a place that's very special to me. This is Frog Valley Studios near Berkeley Springs, West Virginia. I serve as an apprentice here on the premises here, which means I get to do all kinds of things. Today I'll be showing you some things that we do with raku pottery, and later on we'll show you also around the glass studio, and you'll meet some very fine artists who will show you a little bit about the art of stained glass as well.
All right, starting on the gas pressure here.
Amongst the most common and most important chemical reactions in everyday life is oxidation reduction, or redox reaction.
All right, ready?
Yep.
Okay, we've just opened the kiln here. It is still 1800 some degrees in there. Okay, we're doing the farthest pieces.
A redox reaction involves both oxidation and reduction. What happens in the trash can is an example of this reaction.
Ready?
Yep.
More on top. And cover that up. That's good.
The elements that lose electrons are oxidized, and those that gain electrons are reduced.
As we put these pieces in here, what we're doing is a post-firing reduction process. We're making sure that as much of the oxygen as possible is removed from these containers, and then essentially the oxides, the last bit of oxygen left, and they're removed, and you have the raw metal that stays on the surface of the pot.
The glazes contain metals of either the oxide ion, such as copper oxide and silver oxide, or the carbonate ion, such as cobalt carbonate and copper carbonate. The burning in the trash can occurs because of the presence of three elements: heat, fuel, and oxygen. With the lid cutting off a supply of atmospheric oxygen, the nearest available source of oxygen is the glaze compounds, which all contain oxygen. The metals in the glaze components are reduced, while the carbon or carbon monoxide coming from the combustion is oxidized. For example, in the case of copper oxide, which is actually a crystal composed of copper ions and oxide ions, the following redox reactions occur in the can. The copper ions are reduced into elemental copper. The carbon is oxidized into carbon dioxide in the presence of carbon or carbon monoxide. The combination of both reduction and oxidation reactions leads to either of the following reactions. The end result is a shiny copper coating on the surface of the pot that replaces the copper oxide that was present in the glaze before the combustion occurred. What makes raku pots unique is the presence of different metallic streaks that would not form if the pots were left outside to cool down after being taken out of the kiln.
People are really interested in seeing the process that's involved. A lot of people don't really understand what stained glass involves. A lot of people ask me where the kiln is that the glass goes into. I do have a glass kiln, but that's for fused glass, which would be like this. This is fused glass. All the pieces are cut and laid out on this glass and then fired. It's all glass that has the same coefficient of expansion. So that's different than the art glass that I use for my windows. You don't bake stained glass, you lay it out on the table, solder it together. Fused glass, you do bake together about 1400, 1450, depending on what glass you use, degrees. So
Well, now we're in the glass studio. We're going to watch Veronica Wilson do some of the production steps involved in making a stained glass window. When you think of stained glass windows, you're probably thinking about big, like cathedral windows, something of that nature. But Veronica uses a technique called Tiffany glass.
Tiffany style stained glass is different than what you're going to see in the bigger cathedrals and things. We actually create the channel that holds the glass in Tiffany style glass. You get a much finer detail. I can do, very finite detail. I've done pieces as small as 8-9 millimeters, done whole backgrounds in that kind of detail. So you get more life out of the color of the glass.
This is the way it starts, as little tiny pieces that we remove from the pattern and then stick down onto selected pieces of colored glass and then cut around them with a cutting tool.
First you cut the glass, you grind the glass, foil the glass in Tiffany style. You foil it, solder it, flip it, solder it again, clean it, and frame it and hang it up or install it.
Flux is a necessary component in here because it removes any oxides that might be on this copper that would interfere with the flow of that solder. This flux is pretty interesting stuff because there's a chemical reaction there. It contains zinc chloride, which reacts with surrounding moisture to form hydrochloric acid. Hydrochloric acid takes the metallic oxide. The reaction takes place, and what's left is a metallic salt then on the other side of the reaction, and water. And the salt washes away with the water and the flux, and you have a neatly prepared surface that accepts the solder.
When you hold it up in the light and you get light to shine through it, it totally changes the appearance of the glass. So you're painting with light.